All right, so now I have my molecular formulas for ionic compounds. We know how to do that based on the previous lecture. Now, how do we go about naming our ionic compounds? So first of all, let's talk about how we name the different ions. Cations, the positively charged ions, are the easiest, right? K all by itself is potassium. K plus, that ion, we just call it the potassium ion. Magnesium, when it becomes an ion, is the magnesium ion. Aluminum, when it becomes the ion, is the aluminum ion. All you do is stick the word ion onto the name. When we get to those transition metals, those ones that could have multiple charges, we're going to indicate the charge in parentheses using Roman numerals. So chromium with a 2+ charge is the chromium 2 ion, right? You put it in Roman numerals in parentheses. Chromium with a 3+ charge is chromium 3 ion. Okay, so again, because these transition metals could have multiple charges, we have to indicate which one we're talking about in the name. And again, zinc was one of those exceptions. You could call this either the zinc ion or the zinc 2 ion. I'll accept either. This one is considered to be the more correct one because, again, zinc only has one naturally occurring ion, but I don't really want you guys memorizing all those exceptions. So if you just think to yourself, transition metals require Roman numerals, that's going to be the way to go in my course. Okay, so this is perfectly acceptable. If you want to memorize those exceptions and just put zinc ion, that's perfectly fine. But again, I'd like to make it easy for everybody and just say anytime it's a transition metal, we have to put the charge in parentheses. Okay, so let's go about naming these following ions. We have Ca2+. So of course we got to figure out what this is. Let's get rid of all of our little markings. All right, so we have to find Ca, that's calcium. Notice calcium lives in that portion of the periodic table. It's not a transition metal, so we don't have to indicate the charge. This would just be the calcium ion. Pb4+. Okay, Pb is actually over here. It's not, it kind of falls outside that transition metal block, but for our purposes, we're going to consider everything that's, except for aluminum. Aluminum would be type 1. Anything else over here, and it's really going to be like this sort of stretch down here. We're going to consider to be kind of like a transition metal in that we need to indicate the charge in Roman numerals. So Pb is, we could see Pb is lead. I'm sure it has to do with like the Latin name for lead or something like that. But so this is lead 4 ion, right? We have to indicate in Roman numerals the charge on that ion. Okay, and then Ag+1, we're going to go and find Ag on the periodic table. That's here, silver. So this is the silver 1 ion. Silver is actually, again, one of those exceptions like zinc. So if you just said the silver ion, that's perfectly okay. I'll accept that. You don't have to include the Roman numerals if you have those exceptions memorized. Again, I think it's just easier to say, put the Roman numeral on all the transition metals, right? So basically, unless it lives in column 1 or column 2 or it's aluminum, put the charge in parentheses in Roman numerals. Okay. So yeah, I mean, this is just sort of a list of all the different sort of ion names. Again, you could see that they have the cadmium's one of the exceptions, silver's one of the exceptions, and zinc is the last exception. So if you want to have those memorized, that's fine. If you also want to include the Roman numeral just to make it so that all transition metals are the same, that's also fine, right? So on this table, everything that has the Roman numerals is because it lives in the transition metals. Anything that doesn't is because it lives in column 1 or column 2 or is aluminum. When it comes to naming anions, so the ions with a negative charge, those are a little bit more complicated, right? So Cl all by itself is chlorine. What happens is we sort of chop off the end of these element names and stick on an IDE, ide. So the chlorine ion is the chloride ion. Likewise, nitrogen is what we call the element when it's all by itself. When it's in an ion form, the anion is called the nitride ion. Oxygen, when that becomes an ion, it's the oxide ion. Okay. For the most part, you know, again, you're chopping off the back end and sticking on ide. To some extent, you got to have them sound correct. So, you know, an easy mistake that people make is to say that this is the oxygenide ion or something like that. So it is kind of arbitrary as to what portion of the back end we chop off. Eventually, they'll just kind of sound right. We only have a limited number. There are a smaller number of anions than there are cations. So there's a pretty tiny number that you would have to know. Again, oxide, not oxygenide or something like that. Phosphorus becomes the phosphide ion. Nitrogen becomes the nitride ion. Selenium becomes the selenide ion. These are just things that sort of start to sound correct the more practice you have. Okay, so then if we're going to actually name a compound here, let's start with this one here. The first thing you do is name the cation. All right, that's the lithium ion. You name the anion, that's the sulfide ion, and then you just stick them together. So the name of this compound would be lithium sulfide. All right, likewise, in example number 2, we have the barium ion and the chloride ion. Those will just form barium chloride, right? So you're just taking the name of each individual element and stacking them up. The aluminum ion and the oxide ion will form, aluminum ion and oxide ion will form aluminum oxide. So fairly simple to take to build the ionic compound's name. You just have to name each component, stick them together. Things do get a little bit more complicated when you have the transition metals, only because you're including the charge in there, right? So in this particular case, I have the cobalt-2 ion bonding with the chloride ion. So this compound would be cobalt-2 chloride. And actually, this is a good example to work through real quick. If I just gave you something like this, you got to work backwards, right, in order to name the ion. Because this is a transition metal, it's not obvious right from the get-go what the charge on this ion is going to be, charge on this ion rather is going to be. I have to figure it out from this molecular formula. So you're sort of going to work backwards from what we did before. I have cobalt, I have chlorine. Now we're going to work backwards to put those charges in. And we know chloride's -1, right? That's always going to be the case from the periodic table. So in this case, that's balanced. I need 2 of them to balance out the +2 charge on the cobalt. Okay, so yeah, that's how I would have had to have done this step first, kind of worked backwards in order to determine that this is indeed the cobalt-2 ion. And then again, the compound name would be cobalt-2 chloride. All right, so we're going to do another example from scratch, I have Cr2O3. I know that oxygen's always -2, right? But I got to work backwards to figure out what the charge on the chromium is. And in this case, because of those ratios, I know it's +3. So this is the chromium 3 ion binding with the oxide ion to form chromium 3 oxide. Okay, so you got to do that step to, the transition metals are kind of the harder ones because you have to work backwards in order to figure out what the charge is. And one thing I do want to point out, a lot of people would say chromium 2 because there are 2 chromiums there. That's not what that name is representing. It's not telling you how many chromiums are there. It's the charge on the chromium ion in that compound. So that's a really simple mistake people make is, for example, here they'd say it's copper 3 because there are 3 coppers. No, you have to work backwards and figure out what the charge of the copper is in that compound. All right, so here's a little flow chart. Again, these are the differences between the type 1 and the type 2. I'm going to, for simplicity's sake, saying that type 2 is just the transition metals. There are these exceptions here if you want to memorize them, but I wouldn't bother. I guess aluminum is one that I would expect you to know. Aluminum always has a +3 charge. We know that from where it lives on the periodic table. All right, so now we got a few names to determine here. Let's do select ones. Let's do some of the harder ones. We can do a hard or an easy one and a hard one, okay? So Ca3N2. Okay, we're going to first of all figure out where these live on the periodic table. Again, let me get rid of some of my markings. All right, Ca and N. Here's calcium. Calcium always has a +2 charge, so I don't have to include that. It's in one of those first 2 columns. And then nitrogen always has the minus charge, so there's nothing special to indicate there. So this would be a calcium ion and a nitrogen ion. Oh, and of course, because it's a nitrogen ion, we don't call it a nitrogen ion, we call it a nitride ion. So this would be calcium nitride. All right, likewise, Mn2O3. I'm going to look on my periodic table. Oxygen is over here, but Mn is manganese, and that's a transition metal. So all of a sudden I have this extra step that I'm going to have to do, and that is looking at this molecular formula. I'm going to have to work backwards in order to figure out what the charge on the manganese ion is in this compound, right? Because I'm going to have to indicate it using Roman numerals. So MnO, I'm going to do the reverse of what we did before. So this has a +3 charge, and of course oxygen has a -2. So this is the manganese 3 ion and the oxide ion. So those would form manganese 3 oxide. Maybe I was a little messy in how I did it here, but there is no space. There's a space here, but there's no space between the name of the element and those Roman numerals. Okay, so on Canvas, Make sure when you're filling out these ionic compound names, you don't put a space between the name of the ion and those Roman numerals in parentheses. Okay.